Okay, so we're gonna start learning how to graph sine and cosine functions. So I'm gonna use the unit circle that we have at the end of our notes. Remember, I mentioned to you guys before, make sure you guys copy it down. Make sure you guys write everything down on your last paper for the unit circle, because I am going to be using it a lot. For today's case, I'm gonna be using radians. It says graph each function using a radian. So I know your unit circle can be read in degrees, or it can be read in radians. So I'm going to use radians. But let me create a table. Let me create a table of x and y, because I know how to plug in points since I'm graphing. Then I see the values of radians that I'm going to be using. There's 0, pi over 2, pi, 3 pi over 2, 2 pi, and then it starts repeating again. So based on those values of x, again, I'm going to use 0. I'm going to use pi over 2. I'm going to use pi, 3 pi over 2, and then 2 pi. And I know that completes the whole circle. Now, using the unit circle, I'm going to use the y values. And remember it on your coordinates, our x and y value sign, it happens to be the y value. So using the unit circle for 0 degrees, sine is 0. For pi over 2, sine is 1. For pi, we get 0. For 3 pi over 2, my sine coordinate's -1. And for 2 pi, my coordinate happens to go back to 0. Now, if I want to extend my table here, I'm going to say, all right, after 2 pi, I get 5 pi over 2. And then I get 3 pi. And then I could even go more. The interesting part is that sine happens to repeat in 2 pi. We're going to call this our period. We're going to say from 0 to 2 pi is our period. Now, what I mean with period is that how long does it take for sine to repeat? Okay, so start repeating at 2 pi. And I see my values are going to, starting at 0 is going to be 0, 1, 0, -1, 0. So let me start. Starting at 2 pi, it's going to be 0, 1, 0, -1, 0. So I'm going to stop there. So I already have a table of various points. Let me plot them in. Let me use red so we can see them better. So I have 0, 0. I have pi over 2, 1. I have pi 0. 3 pi over 2, -1. 2 pi 0. 5 pi over 2, 1. And then 3 pi 0. I have those points, and if I was to connect them, this is how sine would look like, okay? Now, this is what we're gonna call a pattern, a parent graph. I'm gonna play with sine now. And when I mean with play, question here number 23, I'm gonna add a value here inside of parentheses, right here with theta. Now this value, it's gonna tell me whether I move my graph, whether I move it to the right or to the left. Okay, I'm gonna move it to the right if it's a minus sign, and I'm gonna move it to the left if it's a plus sign. Okay, so it's kind of different in how we usually see it, right? Usually when we see a minus, we think to the left. In this case, it's gonna be the opposite way. If there's a plus sign, I'm gonna move to the left. If it's a minus sign, I'm gonna move to the right. So in this case, I'm gonna be moving to the right, pi over 2 spaces. And then this value at the very end, this number here by itself, is gonna tell me whether I move up or down. Positive if it moves up, and negative if it moves down. Okay, so I know how sine looks like. Then I'm going to be shifting. Shifting means moving. I'm going to move it sideways. So sideways, up or down. So what I'm going to be doing, let me start with a point. So from the original side, I have the point pi 0. I'm going to start with that point. And then I have to move it to the right, pi over 2 spaces. Then I have to move it up 1 space. Okay, so that point, like I said, move it pi over 2 to the right and up 1 space. I'm going to be here. Okay. Let me start with another point. Originally, I have a point 3 pi over 2 negative 1. As a matter of fact, let me do that in blue so we can follow this point along. Again, this point, I got it from just sine, okay? So I'm going to be using this figure. So originally, the point is 3 pi over 2, and then negative 1. And again, I'm moving to the right pi over 2 spaces and 1 up. So it's going to be here. The nice thing about EDIA is that with those 2 points, it gives me a nice graph. So what we're going to be doing, if I'm doing this by hand, each of my points that I have on 22, you guys see my points that I plot in for number 22, each of those points, I'm going to move it pi over 2 to the right and 1 up. Okay, so that will give me, let me graph this really quick here. Okay, now all these points that you guys just see that it just appeared, what happened is that each of my original points on question number 22, each of them, I moved the pi over 2 to the right and up 1. So that's why I came up with all these points. And my graph would look like this. So again, we're going to start with the sine. This is what we're going to call the parent function. So this is where everything's going to start with sine. Okay, get used to the phrase parent function. Basically means where does it start from? And question number 23, I moved it pi over 2 to the right, up 1. So that's how I get that figure. All right, let's move on. Let's take a look at question number 24. Now let me get a parent function of cosine. So let me create a table of x and y values. And because I'm doing this in radians, I'm going to use, for the x values, I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. The period for cosine is 2 pi. So what happens in period again, I said, well, period is how long does it take for the graph to start repeating? So every 2 pi it repeats. Now using the unit circle that we have at the very end, right on the back of our notes, the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. And then it's going to start repeating again, 1, 0, negative 1, 0, 1, and over again. So just to extend this a little bit more, I'm going to say 5 pi over 2 is 0, and 3 pi is negative 1. Let me plot these points in here. And then see pi negative 1, 3 pi over 2 is 0, 2 pi is 1, pi over 2 is 0, and 3 pi is negative 1. So I connect these. And this is going to be our parent function of cosine. Okay, so anything that I do with cosine is going to start with the parent function. And I'm just going to play things over. Now, looking at number 25, I have to move to the left. I'm going to be shifting to the left. And I said to the left because of the plus sign in the center. So I'm going to move to the left 5 pi over 6. And I'm going to move everything 1. So let me plot my points here, okay? Let me plot points. As I'm plotting my points, each of the original points on my original cosine, I moved it to the left 5 pi over 6. Now, some of you guys are like, 5 pi over 6, I don't see how many squares is that. That's almost a whole pi, right? 5 pi over 6, like 5/6 of a pi. It's almost a whole pi. And the whole pi is 4 squares, right? You guys see I'm using the squares here. Almost a whole square to the left. Okay, so each of my points, I moved it almost a whole square to the left. You guys might be like, all right, the way I started was I had originally pi negative 1. Let me do in blue 1 point. From my parent function, I had that point, and then I had this point. Because I got those from my parent function, right? I had pi negative 1, and I had 3 pi over 2, 0. Now, each of those points, I moved it almost 4 spaces, right? A little less than 4 spaces, because 4 spaces is a pi. So each of these points, I moved it almost 4 squares to the left and up 1. You guys notice? So each of my original points, I came out with that. So I have all those points, and I'm just going to graph this. When I connect my points, should look like that. So make sure you guys start with from the parent function. For tomorrow's lecture, I'm also going to use the parent function. So make sure you guys start from the parent function, either sine or cosine. You guys have a list of tables, and then just move accordingly.